Hello friends, welcome to Shiva Sai for You Basic Electrical YouTube channel. So today in this lecture I am going to solve this numerical. It is related to Basic Electrical Advanced, that is network analysis. So the question is, you have to find what is the voltage across this 5 ohm resistance, what is voltage in this 5 ohm resistance, and then power supplied by this 1 ampere current source, power supplied by this 4 ampere current source, and then power supplied by 20 volt source, and then 10 volt source, and then power supplied combining these two voltage sources. What is the power supplied by two voltage sources in this circuit? And also power consumed in this 8 ohm resistance. How much power is consumed in this? So I'm going to solve this numerical using the mesh analysis concept. Okay, so let me consider this is a loop. Okay, loop. I'm going to name the variables like this: A, B, C, T, E, F, G, H, I, and J. Now this is one loop. This is a super mesh. Okay, don't apply KVL for this. So now 1 ampere current source is there. I'm assuming some current is flowing here. So that current I'm naming it as I1 current, and some current flows here. That current I'm taking it as I2, and some current flow in this direction. I'm taking that current as I3 current. Next, current in this outer loop C, D, J, and I, F. So this loop current flowing is like this way. So I4 current. Okay. Now, according to the given circuit, we can write directly what is the value of I1, 3 ampere. So 1 ampere. The value of current I1. See, this 1 ampere current source will flowing in this loop. Okay. The value of I1 directly we can write 1 ampere. Consider this is 1 ampere. Okay. Then similarly, so we can write, see, this one more current source is given, 4 ampere current source. So this current source we can write in a equation form like this: I3 minus I4 is equal to 4. How means, see, these are my assumed direction of current. I3 is flowing like this. Okay, this direction and this direction is same. That's why we need to write plus I3. Now I4 direction, see, I4 is passing like this. So both are facing in opposite direction. This direction and this direction are facing opposite. So we need to write minus I4 is equal to the resultant current is 4 ampere. So further I am modifying this like in this way. So I3 is equal to, I can write I4 plus 4 ampere. So take this equation number 2 and take this equation number as 1. Now apply KVL to the loop B, C, F, E, B. So for this loop apply KVL. Okay. So now forget about this polarity. Forget about this and this polarity. Now simply mark the polarities as per this direction in that loop. So whenever current enters the resistor, mark positive, leaves negative. Current enters, mark positive, leave negative. Current enters, mark positive, leave negative. Like that you enter. Okay. Now according to this direction, you write the voltage drops. Whenever current flows from plus to minus, you should write drop. So minus 8 I2, plus 2 minus drop, minus, what is the resistor there? 5 ohm, minus 5 I2. Then plus 2 minus drop, minus 5 I2. So I got plus 2 minus drop. Now see, this 5 ohm resistance lies between this loop as well as this loop. So therefore this 5 ohm will carry I2 and I4 current. Similarly, this 5 ohm will carry I1 and I2 current. But I am applying KVL for this loop. First, what I written here, so this loop I2 current will take the potential drop of all this, all the combination of this resistor. That is minus I2, minus 5 I2, minus 5 I2. That is what I written. But other current I not considered it. So now for this polarity, so whatever the polarities I mark plus minus as per this direction. So for this polarity, plus and minus, for this direction, you check out, see how this direction is passing, current is flowing like this. It's going from minus to plus. See, this current is entering to this resistor. For this polarity, minus to plus means whenever current flows from minus to plus, you write positive. So plus 5 I4. What is the current in this? I4 plus 5 I4 current passing in this 5 ohm resistance. See, the direction I4 is, see, with respect to this polarity you should write. See, with respect to this polarity, I2 current also flowing here. But see the direction, current is passing from plus to minus. If current flows plus to minus, you write negative. Okay. And if the current flows from minus to positive, you write positive. Okay. Now coming to this resistor, we already written for this polarity, current is flowing from plus to minus means drop, minus 5 I2. What about other current? Other current is I1. For this polarity, minus to plus is rise. So therefore, I can write plus 5 I1 and equate it to 0. This is what the KVL statement tells. You should equate to 0. The algebraic sum of all the EMF sources and potential drops taken with proper sign convention would add up to 0. This is the KVL statement. Now simplify this. Minus 8, minus 5, minus 5. This becomes minus 16 I2. Okay. Plus 5 I4 plus 5. Now I1 value is there. I am taking the value of I1. What is the value of I1? 1 ampere is equal to 0. Now we can write minus 16 I2 plus 5 I4 is equal to 5 into 1 is 5. I am taking to right side. That becomes minus 5. So take this equation number as 3. Okay. See, whenever super mesh is there, we need to apply KVL. Don't consider the super mesh loop. Okay. In that loop, there should be no current source. For such loops, you should apply KVL. Got it? So now, so if I want to apply KVL for this loop, current source is there. So don't apply. If I want to apply KVL for this loop, current source is there. Don't apply KVL. If I want to apply KVL for this loop, current source is here. So don't apply KVL for this loop also. Then identify the circuit. Okay, another possible KVL loop. That loop does not contain current source. So what is the possibility? Voltage is there, resistor, 20 ohm and then 2 ohm. See this outer loop. This loop I am considering now for applying KVL. So KVL to the loop, apply KVL to the loop. So what we can write that loop? B, C, D, J, I, H, E, B. B, C, D, J, I, H, E, B. For that loop I am applying KVL. So let's see. Let's start from this. See now this is my outer direction. Okay. See now as per this current I3 direction, mark the polarity. This current is entering here, na? Mark plus, leaves negative. Okay. That's it. You see the outer direction. This is the loop direction. B, C, D, H, I, B, H, I, sorry, I, H, E, B. So apply KVL. Start from here. Start from here. Minus 8. What is current in this resistor? Only 8 to current. Then don't take this one. Which loop you are applying KVL? This loop. So as per the direction, so current is flowing, your loop direction is flowing from minus to plus. Means you should write positive. So plus 20. Okay, this voltage source will become positive. So next similarly, for this resistor, as per this direction, plus to minus drop. Okay, minus 2 into I3. What is the resistor value? 2 into I3. Then see the direction. And what is our loop direction? What is the loop direction? B, C, D, J, I, H, E, B. As per the loop direction, we can write minus to plus is rise. So plus 10 volts. Then again, for this 5 ohm resistance, two currents will flow in this 5 ohm resistance. As per this direction, okay, I marked the polarity for I2 direction. Plus to minus drop. Minus 5 ohm resistance into I2. Okay. Now what about this direction? This current also passing in this 5 ohm resistance. So for this polarity, so that becomes plus 5 I1. Plus 5 I1 is equal to 0. So by applying KVL to the loop B, C, D, J, I, H, E, B loop, so we got this equation. So we can cross check once again. See, as per this direction, whatever the direction I marked here, that is the loop direction. So according to this polarity, see whenever this current loop direction flowing from plus to minus, you write minus 8, negative drop. Whenever the direction flows from plus to minus, you write drop. What is the current in this loop? 8. That is I2. Minus 8 I2. And see the direction flowing from minus to plus. Minus to plus means you write positive, plus 20. Then this 2 ohm resistance. See the direction, plus to minus, drop, minus 2 I3. Then see the direction flowing from minus to plus, means rise, plus 10. And then see this direction and see the I2 direction. Okay, both are same. And this direction flowing from plus to minus. So drop, minus 5 I2 current. And see I1 current also flow in this resistor. Okay, but this I1 current and this current are facing opposite to each other. So therefore you should write plus 5 I1 is equal to 0. Now simplify this equation, group it all I1 and I2 terms. So how many I2 are there? Minus 8, minus 5, minus 13 I2, 20 plus 10, 30, minus minus 2. What is I3? See, for I3 I am taking this equation I4 plus 4. Okay, I3 is I4 plus 4 plus 5. What is the value of I1? What is the value of I1? 1 ampere is equal to 0. Now group it once again. Minus 13 I2. Okay. Minus 2 I4. Minus 2 I4. 2 into 4 is 8. Minus 8 plus 30. 5 into 1 is 5 plus 5 is equal to 0. Therefore, minus 13 I2 minus 2 I4 is equal to 30 plus 5, 35. 35 minus 8. So, how much we get? 27. You will get 30 plus 5, 35 minus 8 is 27. Plus 27, if I take to right side, it become minus 27. This is, take it as loop equation number 4. Now, solve equation 3 and equation 4 using calculator. Let's see what we get. Okay, go to mode, select equation option, that is plus 5, and select first one, simultaneous equation of two variables. What is our values? Minus 16 and 5. Enter the coefficients. Minus 16 plus 5 and minus 5. Then second equation, minus 13 minus 2 minus 27, minus 13 minus 2 and minus 27. So enter the coefficient. After entering, plus equals. So this is the value of I2. So later we can write by solving 3 and 4. Okay, we get, what is the value of I2? 1.4948 ampere. And what is our another variable? Another variable is I4. You should arrange in the same order, I2, I4, I2, I4 constant, like that. Otherwise you may get wrong answer. Again press equals. You can see the value of I4. The value of I4 is 3.7835. Okay, so we got both the current values. So we got both the current values positive. That indicates, so our assumed direction in the circuit is correct. Okay, so now what is the first question? Find V1. So V1 is calculated as V1 is equal to, so voltage across this 5 ohm resistor. Okay, means see this, it going to carry these two currents, I1 and I2. Okay, so always you write first loop and then second loop, loop 1 and loop 2. See, these two currents are facing opposite to each other. Therefore, voltage drop in this resistor is resistor value into I1 minus I2. So 5. What is the value of I1? What is the value of I1? 1 ampere. So the value of I is 1 ampere minus, so the value of I2 is, okay, 1.4948. So by solving that, we get an answer 5 into 1 minus, okay, 5 into 1 minus 1.4948. So we got a voltage, okay, minus 2.474 volts. Okay, this is the value of V1. Then what is the value of V2? Again same 5 ohms voltage in this 5 ohm resistance. Okay, this 5 ohm resistance, we have I2 and I4, which is having first loop. First loop is this this loop. Later this is the second loop. So these two currents are facing opposite to each other. So therefore you should write I2 minus I4. Okay, so enter all the values. What is I1? What is I2? 1.4948 minus what is I4? 3.7835. So it's done that. So now again you can solve it using calculator. Let's see how much we get voltage in that second resistor 5 ohm, that is V2. So 5 into 1.4948 minus 3.7835, okay, plus equals, see we get a voltage of minus 11.35 volts, that is the value of V2. See, we got a negative voltage. If you change the polarity, you will get plus 11.44 volts, and this also will get plus 2.474 volts by changing the this polarity. Okay, so fine. So after that, power supplied by 3 ohm resistance. Okay, so power supplied by 3 ohm resistance. Sorry, 1 ampere. Okay, the power supplied by this 1 ampere is, see, across this current source from point H to P, these two are connected in series. Okay, got it? These two are connected in series. You already know the voltage in this resistor and voltage of this source. By adding these two voltages, this voltage and the current multiplying, you will get a power supplied by this 1 ampere current source. Okay, so I'll write the value of current is 1 into, there is a voltage 10 volts plus, what is the value of V1? Power in 1 ampere current source is 1 ampere current into across 1 ampere, 5 ohm is there, 10 volts. Add this voltage, and we already calculated voltage in this resistor. So add up these two voltages. So one voltage is 10 volts plus another one is V1. Okay, so what is the value of V1? 2.474. Actually, that is this one, current source into voltage 10 plus V1. So I substituted like this here. So by solving, so you get power dissipated in that 1 ampere current source. Okay, so 10 minus 2.474. See, we got an answer 7.526 watt. This is the power supplied by this 1 ampere current source. Similarly, they asked power supplied by 4 ampere current source. So power supplied by 4 ampere current source, you write 4 ampere current into, see, now in this 4 ampere current, okay, the voltage source is there. Okay, this voltage and this, see, for the power supplied by this source is this voltage drop in this resistor and this resistor. These two are connected across this 4 ampere. So these two are in series, so we can add it. So therefore 4 into 20 volt is there, and then plus 20 volt plus V2. Now enter that value 4 into 20 plus, what is the value of V2 we got? Minus 11.4435. So by solving that, we get 4 into 20 minus 11.4435. So by solving, so we get an answer 34.226 watts. So what is the power supplied by this 4 ampere current source? 34.226 watt. So what is the next question? Power consumed in 8 ohm resistance. Okay, power consumed. Okay, I'll write here. Power consumed or dissipated in 8 ohm resistance will be, see, 8 ohm resistance power consumed. Voltage at this point and voltage at this point. Voltage at this point is V1. Voltage at this point is V2. Okay, so V1 minus V2 whole square divided by this resistance. What is power formula? Power formula is V square by R. But what is our V? V1 minus V2 whole square divided by this resistance. So now enter the value of those voltages. So minus 2.474, okay, minus of, what is V2? Minus 11.4435 close bracket whole square whole divided by that 8 ohm resistance. So that gives the power supplied by the 8 ohm resistance. So I'm going to do that in a calculator. Minus 2.474 and then minus within the bracket minus 11.4435 close bracket whole square. Okay, see, we got a numerator part 80.45 divided by 8. See here, V1 minus V2 minus V2 itself negative. So by all this, we got numerator 80.45 divided by 8. So answer divided by 8. See, power dissipated in that 8 ohm resistor is 10.056 wattage. Okay, this is the power dissipated. Next is, what is the power supplied by the 10 voltage source and 20 voltage source, that we need to calculate. So now, but also they asked what is total power dissipated, power supplied by these two voltage source, 10 volt and 20 volts. So first we can find individually, later we can add it. So now power supplied power supplied by a 10 volt source is equal to, what is power formula? Voltage into current. Okay, in this 10 volt source, if I know what is the current in this 10 volt, current into voltage is power. So voltage is 10 volt into what is current in this 10 ohm resistance. So I1, can we write, see, I1 current and I3 current are facing opposite to each other. Okay, I1 and I3 are facing opposite to each other. So therefore we can write this I3 minus I1, I3 minus I1. Okay, for a voltage source. See, Y means I return, see this I3 direction and this voltage source. Okay, this direction, this voltage source delivering. Okay, it delivers some current, that is I3, both are in same direction. That's why. So if I convert this voltage to current source, we may get current direction like this, upper arrow. That time this both are same. That's why we are writing I3 and then I1, not I1 minus I3. We are writing I3 minus I1. I3 minus I1. So 10 into, what is the value of I3? So I3 we not yet calculated. So what is I3? I3 is I4 plus 4. Okay, I3 is I4 plus 4. I4 plus 4 minus I1. I4 plus 4 minus I1. So now enter all the values. Okay, by entering all the values, so that is 10 into, open bracket, what is the value of I4? I4 is 3.785. 3.7835 plus 4. Okay, plus 4 minus, what is the value of I1? 1 ampere. So yeah, I4 is 3.7835 plus 4 minus I1 value is, see, the I1 value is 1. So by doing all that in calculator, so we got 67.835 watt power supplied by, means 10 volts. Similarly, for a 20 volt, we can write power supplied by 20 volt is, so voltage is 20 into current. See, for this 20 volt, what is the current is passing? I4. Only I4 current is passing. So that current is flowing from minus to plus. So rise. So you should write plus I4. So 20 into I4, that gives 20 into, what is the value of I4? See here, 3.7835. 3.7835. So by that we are getting 75.67 watt. So ultimately the power supplied by the two voltage source, power supplied by 10 volt and 20 volt is, so add the power supplied in each voltage source. 67.835 is the power supplied by the 10 volt source, plus power supplied by the 20 volt source is 75.67. So by adding that, so we are getting 835. So 143.505. 143.505 watts. This is the power supplied in, okay, by both the voltage sources. Okay, got it, guys? Guys, this question asked in NPTEL course assignment 1 network analysis subject. Okay, so it is current running NPTEL course, so maybe it is useful. Okay, thanks for watching. Please do like, share and subscribe. We will upload next another numerical asked in the assignment. Thank you so much.